this is what conventional multiplex PCR looks like. In this case, you see two primer pairs which generate two amplicons. One is the first half, the F1 with the R1, and the F2 and the R2. And this is what happens generally in multiplex PCR. But very often, there are also undesirable amplicons generated between F2 and R1, the smaller amplicon piece that you see here. And those of you who do PCR know that when there are smaller amplicons, they are preferentially amplified. So they sometimes can overtake the reaction. So for most practical purposes, these undesirable amplicons sometimes interfere with regular PCR, and they're best taken removed from the PCR. So that's what SLIMamp does. If you look at the primers now, the primer, let's look at the inside primer, the F2 and the T1. What Pillar has done is attached tags that hang over the primers F2 and R1. So there are these tags, just obviously not specific for the target, so they hang over there. So these overhang, this particular tagged primers goes to 2 cycles of PCR, and it has to go through for 2 cycles at least or more, because it has to read through the hangover and now become part of the amplicon. And over here, what you see diagrammatically again is amplicon 1, amplicon 2, your undesired amplicon now, where these tags have become part and parcel of the amplicon. So you're going to ask me a question. There is also going to be a larger amplicon over there. And yes, there will be a larger amplicon. But remember, I told you earlier that if for a PCRs to be very efficient, it normally will amplify the smaller amplicons before the larger amplicons. And that's why a lot of the larger amplicon is too large, sometimes even for FFPE, and not amplified. Going a little bit deeper into it and looking at it, the particular undesired amplicon, like I'm calling it, with the tags, now, if you think about it, these tags now are complementary to one another by virtue of design. So when you get your single amplicon that is denatured, these 2 tags will hybridize to one another and form a loop. And that is what the loop is. And that's why it's called a stem loop. And because it forms a loop, it now is not available to any further primers for amplification. And by virtue of the stem loop, you are actually removing a lot of these undesired amplicons from your PCR product. It's very simple, really ingenious thinking, but it works really well.